Okay, I'm going to see if I can do this kind of quick. This is talking about the array and using it to demonstrate multiplication and partial products at both the concrete level and the representational level. This is the traditional kind of view of multiplication. 3 groups of 4, right? We get 12, or 12 divided by 4. How many 4s go into 12? 3. So when we're switching over to the array method, we can do it at a concrete level on a multiplication chart to, again, illustrate. So we could say, all right, I have 3, 1, 2, 3, and I'm going to make 3 rows of 4, right? And then you can fill it in this way. This is also a good way to teach area, right? It's the whole area covered, right? So the space covered. And then you'll also see, particularly if this is filled out, that reaches 12, right? Now, there's another way to do it, which is an array format that is shown at the multi-sensory lessons in the multi-sensory course. And it has more of an open array template where you line your things up in your blocks. And the instructor said this is easier for students with gross motor or organizational issues. And what you essentially do is you build the number that you're multiplying by, the two factors on the edges. So you say 3 times 4, touch the products, right? The factors. 3 times 4, and the product is 12. So we're building 12 out of 3 and 4. Now, the neat thing that she showed, which I haven't seen before, is how you can do this with larger numbers. And ultimately transition to using the box method for multiplication, finding partial products, which she says is really important and really helpful for students who struggle with procedures and the more complex procedures involved in multi-digit multiplication. So here we might take the number 12, right? So we're going to build a 12, a 10 rod, and 2 1s. So what's 12 made of? It's made of a 10, see this, and 2. Right? And then we're going to build over here. Let's multiply by, we'll say, 13. Well, I just put them up here, sorry. I will show you. At the representational level, you would just draw this. So then 13 is made of 10 and 3. So the first thing we would do is 10 times 10. 10 times 10 is 100. Hopefully your students would know that, know about adding on the zeros, right? And then we're going to do 10 times this 3. We're going to work our way across. So 10 times this 1 of the 3 is 10. 10 times this 1 of the 3 is 10. And 10 times this 1 is 10. And then we have 2 down here. So we need 10 times one of those 2's is 10. 10 times this one is 10. And then we get over here and we're going to go into, this is 1, this 1. So that's 1 times that 3, 1 times this 3. So we're getting all these smaller partial products, and then we can add it up. So we can see that 12 times 13, the factor is 12, 13, is 156. All right, and then if you want to use the traditional method, you can do that. 12 times 13, 2 times 3 is 6, 2 times 1 is 2, bring down your 0. 10 times 3, we'll just say 1 times 3 is 3, 1 times 1 is this, and we get 6, 5, 1. 156, which is exactly what we have here, 156. At the representational level, you can even go larger with your numbers because you aren't limited by the size of the blocks. So you could do something like 11, drawing a 10 rod. Do 11 times 20. Here's one 10 rod, did 2 10 rods, and then 3. And then you're just going to organize it. So 10. This 10 times 10 is 100. This 10 times 10 is 100. This 10 times 1 is 10. This 10 times 1 is 10. This 10 times 1 is 10. Then we're going to have that 10 times 1, that 10 times 1, and then dot, dot, dot. So what we end up with is 11 times 23 is 253. This works particularly as you transition into the box method, talking about what's it made of, and then breaking them up, and I'm going to show that in another video. I will mention while I'm here that you can also use this to talk about division. So you can say, okay, I have this number, I have, let me just grab a number here. I have 36, right? And I'm going to divide that by 3. So you can say, all right, on this side we have the factor of 3, and we have to line it up and make sure that how can we organize this and see what number is, what, this larger number, 36, divided by 3, how many 3s go in there? Well, it looks like 12, right? And we can build the other factor over here. So we have 36 divided by 3, we're going to get 12. So you can use the reverse as a division.